I'll start introducing our next speaker. All right. Our next speaker is actually a very special one because Sergey is the creator of the Neo4j document store for Haystack. And he's going to walk us through how we might use the Neo4j document store with Haystack RAG pipelines. And this is going to be quite a practical session. And with that, Sergey, the stage is yours. Thank you very much.
Hi, everyone. My name is Sergey. Nice to meet you all, and welcome to the webinar. It was good to hear the introduction to the knowledge graphs and hear the questions about the chunking strategies, etc. I think some of that I will be covering practically in this session. It's not going to be super complicated examples, but at the same time, my goal is to actually show how the integration between Neo4j and Haystack works. And my hope is that everyone becomes familiar what it takes to build a document store, and then it will also encourage people to contribute to both Haystack and Neo4j. A little bit of agenda of the presentation. So I'll do the introduction on why I decided to build this integration. And then, assuming that probably not all the people are familiar with Neo4j or Haystack, I'll just very briefly discuss what it is and how to work with that. And we will start then looking at the Neo4j Haystack Python package and see how it actually works. If that sounds great, I'm going to proceed to the introduction. So the idea of building the integration came after I was discussing with one of my friends how it is the best to organize the legislation in Moldova. I live in Moldova, so we were thinking, okay, it all looks like a graph to us, and obviously I was trying to find a good graph database, as you see on the screen, I will make it a little bit bigger. As you see on the screen, this is an example of how the legislation body looks in the United States of America. It's a Congress, and you see many related parties involved in producing the legislation. And what is most importantly for me was how to represent the legislation, using graphs. And you can imagine a PDF document with different laws represented in that document and links between the documents, and obviously that was very natural for us to think about graphs and consider that with graphs you should be able to navigate that graph pretty easily, and you will see that with Neo4j it's really easy to do using Cipher query language. And apart from that, if you try to combine this structured information with some RAG pipelines, RAG application, then you might look at this, that you can search in graph what you need, and you can enhance the context for the LLM using the structured information. And at the same time, you can use the vector search index that is part of the Neo4j solution. You can use it to query embeddings as well. And you can combine it in a single query in order to get answers, in order to give a context to your LLM. So that was a bit of history. And by the way, Haystack pipelines are also graphs. Here is an example of the pipeline. You can see that Haystack is basically a pipeline of components which are interconnected. And it is an NLP framework that helps you to, do a lot of tasks, basically. But what I'm trying to say here is it's also a graph. It's a directed graph. So everything is a graph, it seems to me. Yeah, so the Neo4j, for those who don't know, the basic structure, when you start working with Neo4j, you need to work on your graph model. And here is the basic graph model for you to briefly understand it. Basically, you have nodes in the graph, you have relations in the graph, and each node can have a label. So that's the way to kind of name or give a name to a node or a set of nodes, I would say. And you can write queries to Neo4j in order to find out more information in the graph. So this is the simple query that tries to find, a person named Dan who is in relationship with Anne. So that's pretty simple. Here is another example of that, a bit more detailed, but important for us for this presentation is that each node in the graph can have properties as well. So that's something that we're going to use as part of our integration with Haystack and in our examples. How would you work with Neo4j? In this presentation, I'm going to use the free cloud instance of Neo4j Aura. This is how it looks like. This is the instance that I started before the presentation. And there are many other options you have. If you're working locally, using Docker is also very easy to install Neo4j. And that's how I actually was testing Neo4j integration with unit tests. I was using Docker to automatically start the instance of Neo4j, run the test, and then destroy the instance. So I was using Docker in the integration as well. Okay, so in order to start with something, I wanted to, first of all, to run some example. And for that, I'm going to create a simple graph. I am opening the application called Neo4j browser. And we'll type in command called play movie graph. So this is the special command which starts tutorials, right, guides, which help you to learn Neo4j and Cypher in particular. But I'm pretty much interested in this Cypher query, which inserts movie data into that database. So that's what I'm going to do. And as you see, as a result, we got a simple graph. We got movies with its properties. Each movie has tagline, title, and there are people who relate to that movie, like actors, directors, and there are relations like the director directed this movie and the actor acted in this movie, right? And with that, having some data in our database, let's install a Neo4j Python driver. So this is the package which is shipped by Neo4j, and it helps us to query the database in Python. And what I'm going to do is create some helper utilities for me to be able to query it without repeating code. And because we uploaded the data, I can query it. So you can see I'm trying to find Tom Hanks, and I was successful in that. And another example here is that with Cypher queries, we can find information by giving some more conditions, right? Apply some filtering. This is important because document stores in Haystack, they allow you to do metadata filtering. And actually, under the hood, what Neo4j Haystack package is doing, it converts the metadata filtering with the Haystack syntax into the Cypher syntax. So we will see how that works as well. Vector indexes in Neo4j is something that you can have both along the very close to the graph. Basically, you create an index with the simple command like this one. So you have a create vector index, you name the index, and what's important when you're creating an index is you specify the name of the index, the label of the node which you try to index, So basically, Neo4j in background is going to be looking for all the nodes having the label movie, and then we will be looking for the embedding property of that node. And if there is such, it's going to be indexed automatically. And also we are giving dimensions of the vector. It depends on the model that you're using. In my examples, I'm going to use sentence transformers. And similarity function, at the moment, Neo4j supports cosine and Euclidean distance. So we created an index. We can query to see if the index was successfully created, and it was. And after that, we can try to work with embeddings. So while it's being installed, my goal here is to create embeddings for the taglines. So if I open the browser and I open a movie, you see that each movie has a property called tagline. I'm going to use it, use this text and embed it using sentence transformers. And I'm going to store the embedding back in this property in the movie. And then we hope that vector index will pick that up automatically for us. So while we're waiting the installation process, I will move forward as well and talk a little bit about Haystack. So this is the ecosystem of the Haystack. It's not all the things that you might have in Haystack, and you can go to the documentation website for version 2.0 and find all the components that are available in Haystack. In our case, we are particularly interested in document stores and data classes, some of the data classes. So why? And apart from that, you've got a bunch of components. So in Haystack, you basically have components which are defined by some parameters. So before you create a component, you need to specify parameters which influence the behavior of the component. And then you have a very interesting method called run, and each accepts parameters and returns output. It pretty much like any other component, right? In any other frameworks that you know about, we have inputs and we have outputs, and that's how they work in the pipeline. The data class, which is the documents, and this is one which I'm interested in. This is the, I would say this is the main currency in a Haystack framework because it's the main data structure that flows in the pipeline. It's not the only data structure that you can have, but practically this is something that most of the component worked with. And we will have to use it to see, how we can bring together Neo4j and Haystack and using documents. So let's see if sentence transformers have been installed. Yes, and let's try to create embeddings. All right, so most probably we are downloading some information about the model, which is this one, which we're going to use for encoding our tagline for movies. And if the process has finished without any issues, we should be able to, again, find all nodes. And let's pick up some movie. And you see that we've got the embedding property in that movie. So having that embedding property means the index should be updated. We should expect that from Neo4j. And we should be able to query it. So there is a simple query. We're trying to find a tagline, correct the cipher, which is semantically similar to that. And what we're using is a specific procedure called query nodes in Neo4j. So we're searching for movies having a tagline, which have similar meaning to correct the cipher. And then once we found those movies, we return it, basically, along with scores. Let's see if that works. All right, so you see the first tagline for the movie is "Break the Code." It looks similar to me as the Crack the Cipher. So I think it all worked well. Okay, let's get back to document stores. The document store is the main structure that is delivered as part of the Neo4j Haystack package. And as you see, whenever you want to build a document store, you need to implement these methods in your solution. That's what I done. I created a class called Neo4j Document Store, which implements this sort of interface with these methods. So let's try and use our document store in practice. And before that, let's look just a big picture, right, of what is delivered as part of the package. So on the left, you've got a pipeline, a Haystack pipeline. This is the quite typical rack diagram. But you see in the diagram that we have a retriever component called Neo4j embedding retriever. And if you follow the line, you'll see that it comes from the Neo4j Python package. So you have to install it before using it in a pipeline. And apart from the Neo4j embedding retriever, we got the Neo4j document store and another pretty interesting component called Neo4j dynamic document retriever as well. And we also use the Python driver that we used before to interact with Neo4j database. So it is hidden for us. Everything is handled by Neo4j client. You will not probably use it from this package, although it is exposed, like you can import it and start using it. But basically the responsibility of Neo4j client is to hide all the interaction with Neo4j for Neo4j document store. All right, so let's try and install our Neo4j Haystack integration package. I think sentence transformers are already installed, so it shouldn't consume much time.
I think Sergey has frozen, so let's give it a few minutes and see if he comes back. Okay, you're back. All good.
Oh, sorry. Was I off for a minute?
Yeah, but just for like 5 seconds, so we didn't miss much.
Oh, okay. I will share my screen again. Oops, not this one. Can you see Google Colab?
Yes, you're back at the same page.
Cool. So I'm not sure if you heard about the Neo4j document store. So it's a component that we can import from the package that we have just installed with a bunch of settings. It's important you specify the index that we're going to use for storing vectors, and also the node label that we are going to use for searching for vectors, and also the field, the node property name, which are going to store the embedding, and the similarity function as well. You've got also a bunch of other settings as well. For example, verify connectivity. If it's set to true, it will check if it can connect to the database without any issues, basically. So while it's running, I'm going to further discuss what else is available in the document store. In particular, there is a method count documents, which allows you to count the documents in the store. But also there are more methods. Like you're not limited to just count methods. You are free to add, when you implement your own document store, more methods. And that's what I've done. There are more methods available for you to use. Some may be useful, maybe not. So we will see what else is provided as part of the package a little bit later. And this is how you can, extract the connection settings from the document store. There is a separate data structure. You can hold, connection settings in there. This was done for code reuse because client configuration and the way you connect to Neo4j is not only used by Neo4j document store, but by the other component as well. So writing data to document store. I prepared a JSON file ready to be imported into Neo4j. For that, I'm going to go back to the instance and clean it up, because before we got the movie graph in there. So I'm starting clean with that. And what I will try to do is import the data into the Neo4j. Let's see if I was successful with that. We still got movies in here. Yeah, sorry, this code just parses the documents, and in order to write the documents, we need to call the document store write documents. And as you see, we've written 40 documents into Neo4j. And let's try and search documents with label document, because that's what we specified in the document store. And then we return the documents. And you see, we've got the document content. This is something that we've got parsed from the JSON file. And we got a bunch of other attributes like genres, genre, and runtime, etc., which we can use for metadata filtering as well. Metadata filtering is being able to retrieve subset of nodes, basically, using document store capabilities. So after we written the documents, well, we can get a document by ID. By the way, this is additional method, right? It's not available as part of the document store protocol, but it was added for your convenience. This is how the document is represented in Haystack. And this on the right-hand side, this is what we actually store in Neo4j. And you can clearly see the mapping, how it happens. So the content goes to node properties of the node called content. And we've just seen it in the Neo4j browser. All right, so I will go to the pipeline. So we've covered sort of main components of the document store, main methods of the document store. You can write documents, you can count documents, you can also query documents with embeddings. But the best way to do that is through a Haystack pipeline. And what I would like to show you is a little bit more of a standard pipeline, but also one that is not standard, which is a little bit more advanced, I would say. So the standard pipeline would be the RAG pipeline, which is usually called generative question answering pipeline. And what you do is you create a document store and you give the prompt template to the LLM. This is a prompt template which uses a special syntax called the Ginger, if I'm not wrong. And you can basically build very sophisticated prompt templates in that case. And this pipeline answers questions about, Game of Thrones wiki. And in that case, we're using document store, which is used in conjunction with the Neo4j embedding retriever component. Those work together. I would say probably most of the time you would use them together. So whenever I create embedding retriever, which is responsible for going to Neo4j, extracting the graph nodes using the vector search, and also returning them back to the pipeline. And then we can use those documents, which are being retrieved from Neo4j, back to our prompt, where we can construct the prompt and answer the question. And because we don't have that much time, I will jump to the another example of a pipeline, which is a bit covers a bit more complicated scenario, is when you have an existing graph. And as we already talked about chunking strategies, etc., you could potentially have a lot of structured information, and then you might have the unstructured information, but still you might store it in Neo4j. But you may choose not to store it in Neo4j. It might be stored in another place, but you still want to combine both data from Neo4j graph in your pipeline along with the textual information that might be stored somewhere else, for example. And in that case, document store might not help you because most of the time it works with documents. And the way it works is that once you create a document, it is the only data interface between Neo4j and document store. And for that reason, I created a Neo4j dynamic document retrieval component. And you can basically, with that component, you can run any query in your RAG pipeline and extract any data in Neo4j. In this particular case, what I'm trying to achieve with this pipeline is that I'm trying to find taglines in a movie. And once I find taglines, I also aggregate the movies, and along with movies, I try to find directors of those movies. And I take directors and movies and the taglines which belong to the movie, and I'm trying to give it to LLM in order to answer the question about the meaning of the tagline. You know that tagline are short and shiny descriptions, and it is maybe sometimes hard to decipher. So LLM is going to write an email to director asking about the meaning or guessing the meaning of the tagline. Sorry. And in order to implement that in Haystack, I would suggest you to use the Neo4j dynamic document retrieval. And what it does is it runs the query to a cipher query, which is maybe a bit more complicated than usual, but I can explain line by line what it does. It goes to Neo4j and finds the taglines, the movie taglines, and then returns the movies along with the scores. Once we found the movies, we find the actors and directors for that movie. And then with that information, we return it back to Haystack. And Neo4j dynamic retriever is going to look for what we are returning from Neo4j. And our job is to make sure that what we are returning looks like a document, a Haystack document. And you see, we have a content field, we have score, but also we include directors, which is additional metadata that we're going to use to ask the question to the director. And here is the prompt. Once we got the movies with its taglines and directors, we ask LLM to write a letter to director explaining the meaning of the tagline. I've tested it with Mistral. It worked well. Once I chose a larger model, it went even better, to be honest. But it worked pretty well. And Neo4j dynamic retriever can help you also with other scenarios like parent-child chunking strategy. When you have a big document and then you chunk it into multiple sections, and then those sections you might want to further chunk into more chunks, and then you will get a complicated graph, which might be interconnected with structured data as well. And again, Neo4j dynamic retriever can help you write a query which will return you, which will first search for chunks based on the embeddings, and then search for parents of those chunks in order to aggregate all those parents. And that is what we are going to give to LLM to answer the question or do the job that it's intended to do. Yeah, unfortunately, we don't have much time to run all these pipelines, but this notebook is going to be shared with you, and you will have opportunity to test it yourself and see how it works in practice.
Thank you very much.
Yeah,
It was really nice to see the Neo4j document store in action, and thank you very much for creating it for us.
Thank you.
All right, with that, we're just 5 minutes before the hour. I'll share my screen again, just to let you know about the upcoming events we have. Hopefully you can now see the screen. And if there are any questions to Sergey, please drop them in. I know I've been seeing Andreas doing a really good job of answering all of the questions that came through. So we do have a couple of minutes to answer any specific questions you might have for Sergey. I did see a couple of questions coming up about the recording, just so that everyone knows. If you signed up to this event on Luma, you'll get it as a notification or an email. I'm going to make sure I upload this hopefully tomorrow. If not, we'll also be announcing the recordings on the Haystack Twitter account and the Haystack Discord. So if you don't follow us there or you're not a part of the Haystack Discord, please join us there, and I'll make sure to announce it hopefully tomorrow. I think both of the recordings can go up tomorrow. And I'll also make sure that we're sharing all of the relevant resources with you. All right, with that, thank you very much to everyone who attended. Thank you very much to our speakers, Andreas and Sergey. This was really a pleasure. And honestly, it's also our first Haystack 2.0 webinar, so it's extra special. Thank you very much for taking part. All right.
Thank you.
Thanks so much. It's great to have spend time with you both.
All right.
Bye-bye.
See everyone next time. Bye.